So it basically gives you these two vectors, 1, 8, 2, and 2 lambda squared, negative lambda, and 4. So lambda is just some constant, just a number. Okay? And it asks for the value of lambda for where these two vectors will be perpendicular to each other. We've just done it on that side. Okay? If they're perpendicular to each other, okay, it means that the cosine of 90 degrees will be equal to 0. And remember, we're looking at cosine of 90 because we're trying to relate it to dot product, the angle between two vectors. I also know that the cosine of theta is going to be the dot product of these two vectors divided by the product of the magnitudes. Okay? So therefore, because cos of 90 is equal to 0, I'm expecting this thing to come out as 0. If they're perpendicular, I'm expecting this thing to come out as 0. Does that make sense? Yeah. Okay. And of course, this thing here can only ever be positive or 0. Yeah? So therefore, u dot v, if I multiply through by this, u dot v is going to come out as 0. That's the condition. If they're perpendicular, and in fact we came up with this over here as well, if they're perpendicular to each other, it means that the dot product is got to be 0. Is that okay? Right, so therefore, let's take the dot product of this thing and set it equal to 0, and then find the value of lambda where that's satisfied. Yeah? So dot product of this thing is going to be 1 times 2 lambda squared plus 8 times by negative lambda plus 2 times 4. And of course, if they're perpendicular, this has to be 0. The dot product has to be 0. Okay? So let's have a look. Right. Let's solve this. 2 lambda squared minus 8 lambda plus 8 equals 0. That to me looks like a quadratic. Yeah, so let's divide through by 2. Lambda squared minus 4 lambda plus 4 equals 0. That should be easy enough to solve. What do we get? Yeah, so lambda minus 2 all squared has got to be equal to 0. So therefore lambda minus 2 has got to be equal to 0, which means that lambda has got to be equal to 2. Nice? Good question?